All right. Tomorrow is part 2 of your evaluations. Okay? So keep in mind we did an activity over this to, I don't know, maybe help explain it or help you visualize what Bohr models actually look like. Okay? Because when you do that on pencil and paper, that is just, of course, two-dimensional. When you do it on the activity that we did, that represents 3 dimensions then, because you can actually visualize what's inside the nucleus. What particles are inside the nucleus? That's 1. And those 2 numbers together are important. Why? Protons and neutrons. That gives you the atomic mass. Okay? So then, if an element is neutral, so go ahead and pick any element on your table. So I would, if you want to follow along, fine, but you should have your table out. When I say follow along, I mean with a piece of paper. So while you are doing that, pick any element on this table, asking for some input. Cesium? Okay. So, okay. There's a lot of things that I would expect you can tell me about cesium by looking at this table. So, when you picked it, I'll give you a little hand. It's element 55. Okay? So, what is everything that you can tell me about cesium when you see, just a moment here, just on account of, this is a little small for me too.
Let's do it. Let's do it.
Okay, so what we had learned, what is everything that you can tell me about cesium? Now, you don't need to tell me the name because we have the, okay? So if this is neutral, I would expect that you can tell me everything about cesium with its subatomic particles.
It has 55 neutrons. Protons.
Well, I heard both, so which is it?
Protons.
Okay? Because this is which number? Is the atomic number. It helps identify which element it is, rather than, for instance, when we go and talk about these different elements, if we say, okay, I want to talk about element number 50, okay? Rather than saying find tin on this table, once you hear element number 50, all you have to do is look for somewhere on this table a little number 50. Not 50 point something, because the atomic numbers are whole numbers. In other words, they go 55, 56, not 56.3, not 57.1. Atomic masses do that, but the atomic numbers are on whole number increments. Okay, so if it is neutral, then what can you tell me about this with its electrons? Okay.
No, 55.
I heard 133, so that's what we put there. Okay? How many neutrons would cesium have? Okay?
No.
See, it's all right to make mistakes, because once you've seen that, oh, I made a mistake, we hopefully will not repeat them, and we will not learn, or that we will learn from them. Okay? So 78, I'm presuming, is this number. Then we should know this one. Why would it be 55?
Because it's neutral.
Well, true. But it has 55 positive charges, and it's got 55 negative charges. So when you say neutral, that adds up to 0. And then, of course, this is just from subtracting each other. Okay. So let's do the Bohr model for cesium.
Okay, let's do it.
Does someone want to come up here and do this? I will shut the camera off because I can't have that rolling with. You did that last time, and I don't think that went too well. Well, do it on your paper.
Okay.
Just want me to do this, or someone else want to come up here? I told you already. Okay?
I'll do it.
I know any brother.
All right. So I will hit pause. Okay, I guess maybe if we didn't have the camera on, too bad we couldn't have that just the voice recorded, because if you are helping someone with this, okay, we just don't want you to, that's why I said, let's stop. Okay, explain this as we go. As you can tell, that's obviously not my handwriting because it's a lot better. Okay, so when you follow that slide rule, the big number 1 is telling you what? Big numbers tell you which energy level you're in. Okay? Letters tell you what? What block you're in. And then what column also tells you something. Okay?
How many electrons?
Can be. Now, question was, why is there an E here? Well, sometimes if you write a 1, that 1 will just blend in with the energy level. Okay? So use this periodic table for your advantage. What period is cesium in? No. It's in the 6th period. So that means if it is a 6th period element, how many energy levels is that going to be? That's why you see 6 out here. Okay? Now, don't use that correlation for D block elements. Those are a little more trickier. Until you get to an advanced understanding of this, you'd have to do something called N-1, which does not mean anything to you right now. Only if it's an S or P block element can you make those predictions. But anyway, what else can you tell me about this element cesium? We know it's in the 6th period, so that's why there's 6 energy levels. We know what block is it in.
The first. No.
It's in the S block, so if an element is in the S block, it can only have how many electrons? What or what? It can only have 1. Because if you add 2, then you're right next door to not cesium, but Ba, right? What's Ba? Barium. Okay? So, what else can you tell me about this? What column is cesium in? Why is that important? This will tell you. Okay? It has 1 lone valence electron. So, we could jump all the way down. What? Sodium or potassium? You pick. Okay? So, what element is sodium? When we say element, we mean atomic number. We said sodium. Okay? So, there again, we're going to follow this similar pattern. Your slide rule tells you, big number 1, first, energy level. S block. How many elements can fit in the S block? Okay, and we're going to put both of them in there. The slide rule then moves on to a big number 2. That number 2 means what? Need a new energy level. Okay? And what block are we in? 2s, right? Okay? So 1s2, 1s2. 2, 2s2, 2s2. Okay? Then why is this 6 here? What does the slide rule tell you?
That
Okay, remember 1, 2. So 1s, 2s, 2p. Here we are. 3s is down here. Okay, so these big numbers are telling you which energy level you're in. Okay, so 2s what? 2, right? That's where that number comes from. What does the slide rule tell you? Are we going to go into a different energy level? No, because this number is what? Still in the same energy level. And how many columns are in the P block? Are we going to put all 6 of them in there? Yes, we are. Okay? Because all of the numbers out here need to add up to what? Need to add up to 11. How many do we have so far?
11.
Right. So then as you keep going down this slide rule, you have the same information in front of you. Okay? What does this tell you? Need a new energy level. There it is. Okay? And what block are we in? The S block. Are we going to put both electrons in here? No. Okay? Because what column is sodium in? The first one. So we would just put an E here. So letters and numbers added together is what? 11. So what can you infer from the element cesium all the way down to the element sodium? Just by looking at this. They only have one valence electron, so they're in the first column. Okay? Remember, electrons determine that element's reactivity because they get gained and lost. This is going to be new material. Okay? It's not rocket science because now for those of you who choose not to write this down, who choose not to pay attention, who choose not to participate, do you see a pattern here? Yeah. A lot of choices. And a lot of And a lot of not choices. Okay, that's not how I would say it, but it's kind of a different way of going around the barn. Okay? So what happens with this, I'm removing that electron. Okay? So how many positive charges does this sodium have? Still has 11. Okay? I should probably use a darker color because you probably can't see that very well. Okay? Then we're just going to do the electrons now. How many electrons does sodium have?
11.
How many electrons does sodium have?
A bunch of them hoes. 11. 11. Negative 11. 11.
Why are you right? What did you add together to get 10? Plus 2. Yeah. 6 plus 4, right? Okay. 2 plus 6 is 8, plus 2 more gives you 10. Okay, what type of charge do electrons have?
Negative.
What happens when you add these two numbers together?
You get 1.
Look inside sodium's box. What do you see inside that besides 11, besides 22.99, besides Na? You see plus 1.
Wait, so how come there's not 11 electrons? Because we took away the...
Because we took away this electron. Because what we want to illustrate is why does sodium form a plus 1 charge? Because you see that on your table. If that electron gets removed, okay, that's how you would draw the Bohr model for that. So we could do something very, very similar. Okay, so pick an element between 13 and 18. 16. So the moment that you pick element 16, that means we are choosing which element? Sulfur. Okay, So here's sulfur, okay? And I'm going to tell you to draw that with a -2 charge, okay? So if you have to draw an element with a negative charge, does that mean it has more electrons or less electrons?
More.
Well, it's either more or less. The math will tell you. The math will work out for you, okay? So this will never change for sulfur. How many electrons are in the nucleus? Excuse me, how many protons are in the nucleus? Okay. Now remember, this whole thing is going to have a -2 charge. Okay? We're still going to follow the slide rule. What is that telling you? We probably have said this probably 50 times by now. You might say, no. Not that we can go back and look at this on the Science Channel, but that big number 1 is telling you something. The energy level. Okay? So how many electrons are in the S block? Just like up there. Okay? What is this telling you? You need a new energy level. Okay? And how many electrons will we put in the second energy level of the S block? Just like we did up there. Okay? Then, what is this telling you? Are we still in the second energy level? Yes, because that's telling you that right there. How many can the P block hold? Are we going to put all 6 of them in there? Yes. Okay? Just like you did up here. Okay? Now, what is this telling you? Okay? So that means 3s what?
2.
Okay? Okay? So if we climb, we're at the bottom of this slide. We're going to climb to the top of this one. Are we in a new energy level? No, we're still in the third. That's what the slide rule is telling you. You're still in the third energy level. Now, what column in the P block only is sulfur in? Okay? But this is where it gets to be a little tricky now. Okay? Right now, if you add together all of these numbers, what do we get? 16. That's 16 negative charges, 16 positive charges. Okay?
So we make a new energy level.
No.
No, you just make it 6.
Because, say that again. Nope, you don't get rid of 2. Okay, keep in mind. Okay, here's sulfur. Okay? Because you correctly said it's in the 4th column. Okay? So, how many more columns are in that P block?
6. I meant not 6.
2.
There's still 2 more, right? Once this holds 2 more, now that energy level is full. Now, add together. Now, you would think so. You said, oh, now we got argon. No, we don't. If you go by this, yes. But we did not change our atomic number. Okay? So add together all of your letters and numbers. Okay? So how many positive charges does sulfur have? Okay? Now, letters and numbers. How many are outside of the nucleus? 8.
Letters and numbers combined.
I heard 8.
Negative 18.
Add those together.
Negative 18.
We had 8 here, though.
Nope, you have to change to 18.
Okay? So letters and numbers together is what? Now add these 2 numbers together.
Oh my God.
Just like what we were saying earlier. That's why it's a negative charge, because it has 2 more electrons. Okay? Now, we could do the same thing again with this cesium. Okay? If we take away 1 electron, okay? How many positive charges does cesium have? Okay? Now, if we were to add together all of these numbers, okay? 1, 2, 3, 4. 4 times 6 is what? 24, right?
Yep.
2 times 10? Okay. 1, 2, 3, 4, 5. 5 times 2 is? Okay. So 4, and we get 54, right? Is that math correct?
No. Yes. Because it's a positive charge.
Why is it wrong?
I was kidding.
Oh, okay. So what's so funny about it?
Nothing. I'm just an optimistic guy.
Okay. So now, how many negative charges does this cesium have out here?
Negative 54.
What happens when you add those two numbers together? So what does it say inside cesium's box? Element 55. It says positive 1, correct? Okay, so you will be responsible for drawing elements with charges. Okay? Front row, who does not understand that? Because if you don't, you've got to say something. If you are nodding your head like this, you are saying, I understand. So first row. Second row. Third row. Okay? There's only one individual who's maybe being honest. So should we have someone else come up here and explain how an ion is formed by using this logic, since everyone's going like this? Right? We should be able to do that, correct? Because that's what you're saying when you're going like this. So if you can do it today, logic says you should be able to do it tomorrow. Okay. So I'm going to put this electron back in here. What is a configuration now? It's a linear depiction of it. And if you have problems with configurations, I'm good at Bohr models. We'll draw the Bohr model first, and it follows that same pattern. Okay? So, what noble gas can we use?
Xenon.
No. Yes, you can. I was thinking we had to use krypton. We can use xenon because that's 54, correct?
6s1.
Okay? And this is how we explain it. What period is xenon in?
5.
The fifth one. What block is xenon in? It's in the P block. What column in the P block is it in? So that means that what comes after 5p6 on your slide rule? Okay?
6s1.
What happens when you add 54 plus 1?
55.
You get 55. Okay? We could do the same thing if you went longhand with that, just to show you that it's a linear depiction. Okay? So if we were to do this cesium, okay, it's element 55. Okay? 1s2, just like we did there, comma, 2s2, just like that, 2p6, okay, 3s2, 3p6. Then what happens after this one? The slide rule tells you something different. What comes after 3p6? Even tells you that here.
4s.
Okay? Okay? Then there's 4s2, correct? Oops, this one. Then what does it say? 3d what? 3d10. Okay? Then what do we do after that? 4p6, right? Okay. Then what? What comes after 4p6? 5s2? Okay. Then looks to me like we're missing another. Okay, add together these exponents. 2 and 2 is 4, plus 6 is 10, 12, 18, 20, 30, 36, 38, 48. We're off by a little bit. It's a lot easier, isn't it? Okay, so that's why, yes, use your noble gas core. Okay, is there any other element you want to do a configuration or a Bohr model? Now's the time, and if you're absent today, it's your responsibility to do that. Yes, to watch the Science Channel. If you don't understand, you've got to ask questions. Okay? It's a choice you need to make. All right. Is there anything else? Going once. Going twice. Okay. Is there anything else, though? Oh, how soon we forget. Upperclassmen know what that means. Because it's something that I said that I would give to you on Monday.
Exam?
No.
Bonus questions.
Bonus questions. But you laugh at this. People aren't going to do their bonus questions because we don't want free points. They're free, but you don't want something that's free.
Whoever said that, if it's free, it's for me.
So why do this if it's free? Free points.
Because it's for me.
Let's just skip. No one wants free points anyway.
I do.
I'll take some.
Okay. So, what that means, okay, this has to be turned in tomorrow. Okay? And you have to have the question and the answer. So, just a quick reasoning behind that would be, like, for instance, if the question was, who won the AFC championship yesterday? You need to have that wrote out, and you need to write Kansas City. You just don't write Kansas City on a piece of paper and expect to get credit for it. You have to have the question and the answer. Because if you no, you don't even have to do that. If they're not signed, you're just missing out on more points. Again, that is a choice. Okay. So, that's supposed to be a K. We say chains, we mean log chains. We're not talking about a little type of bicycle chain, okay? They use chains and blank, okay? So what that means is these chains have to be held on. You just don't tighten up the chain as tight as you can with your hands. It will never hold your load on the semi-trailer, okay? So it's something that has a hook on this side, and it's got a hook on this side. Then there's probably a big lever on there. That big lever is something that you pull that really, really increases that tension on there. Now, some of these are ratchet strapped, but in this case, it's got a big lever on there that you might pull back down in this direction, and that really tightens that chain on that trailer. So then your heavy equipment is not going to hopefully fall off. Okay.
Is it a ratchet?
You don't use ratchet straps and chains together. No, I highly doubt it. Okay. Okay. And then, let's see here. I'm going to hit pause for just a moment. Okay, I'll give you a little bit of context for this second one. Okay. So which infantry division, okay, of course there's lots of different numbers. The 1st Infantry Division, well, let me back up. Does anyone know for the National Guard what South Dakota has for a combat patch? The Army has this combat patch on their left shoulder. It's an animal.
Eagle.
No. You're not too far off. I mean, South Dakota is known for their pheasants, but what other animal might that be that's associated with South Dakota? No. Coyotes. There is a coyote patch. Okay? South Dakota's combat patch is a coyote. Okay? When you say eagle, that's the 101st Airborne Division. Okay? But in this case, which infantry division has a combat patch with lines? It is the blank. In other words, the 1st Infantry Division just has a number 1 on here. The 2nd Infantry Division has a Native American with a big star. That's the 2nd Infantry Division. The 3rd Infantry Division. Okay? Okay? So, anyway, so sign it if you so choose. So it's an infantry division that looks like this. All right, a combat patch. We will catch up to you next time. Exam tomorrow. If you are missing work, you are not doing yourself any favors. I believe that grade book is as updated as it can be. If you have problems, you've got to say something, okay? We'll catch up to you next time.